Hello, my name is Dr. Muthanna Abdelmajid Jamil. I'm going to show you my film Effects of the Electromagnetic Fields on the Solid Dust. Film content. The present film introduces the following major items: summary, introduction, theoretical aspect, experimental work, results, general conclusions, discussion on vehicles dust, the word requirement, references. Film summary. The present film will introduce the electrostatic and magnetic forces as a modern technique to precipitate the microns and submicrons particulate pollution, which could be emitted by nature or due to the human activities. Introduction. Those fine particles like lead, magnesium, iron, etc., which makes hazardous to our life, particularly for the human health, causing irritation to the soft tissues, lungs, cancer, and nervous sickness, as well as poisoning our foods. They are originated from dust sources. The original of the dust generation could be from one of the following sources as shown on figure 1. Natural, from the solar storms, wind and sand, volcanoes, and artificial, from the combustion explosions or a process like milling, painting, and factories, etc. Their distribution, types, and filtration technique are shown on diagram 1. Precipitation techniques. The specialist scientists like White, Weinberg, Shapiro, and many others have been work very hard and serious to investigate many techniques, searching for the optimum one to minimize the emission and capture those particles shown on diagram 1. The developed techniques depended on the following forces: gravity, Coulombic, viscosity, magnetic, electric, thermal gradients, mechanical, and live tissue filtration absorption. Working conditions. Each of the above techniques have its own working conditions and their special advantages and disadvantages. Their work were depended on a number of factors like running conditions such as temperature and pressure, collection efficiency, economic, engineering-wise for space and safety. In the present work, and due to our conditions, we chose technical 2, 3, and 4, while the others of less efficiency. Theoretical aspect. The major forces which control any precipitation process could be one of the following: thermal and viscous, gravity, Coulombic, electric, and magnetic. In the present work, we charge the electrodes, while the particles could be charged naturally or by the applied fields, or could be charged by one of the following methods. I. Friction, the amount of charge representing by question 1. 2. Hot charging with zero field intensity, and the particle charge can be calculated from question 2, whether it's positive or negative. 3. Hot charging with zero field intensity, and the amount of particle charge per time can be calculated from equation 3. 4. Thermionic emission with zero field intensity, and the A rate of charge can be calculated from question 4. For experimental work, the present practical work can be divided into two parts. A new work. The new research system consists the following main techniques. Number one, laser velocimeter or anemometer for both particle sizing and the flow velocity measurement, which shows on figure 1. Figure 1 shows the laser Doppler velocimetry, on which you can see the laser head, the optical unit, the photomultiplier, and the measurement chamber with the thermocouple wire and digital thermometer. Number two, the electrostatic precipitator system for particle precipitation experiment, which shows on figure 2. By this system, we did the experiment measurement, which involve the following type of fuels: benzene C8H18 and diesel C11H24. Figure 2, the present experimental system, on which you can see the engine, the exhaust line, the two precipitation electrodes, the voltage supplier, and the avometer, and the thermocouple wire and digital thermometer. 5. Results. 5.1 Mass deposition. The obtained result on the particles precipitation mass rate for benzene fuel are shown on figure 3 for various polarities and various voltage. While for diesel type, similar results are shown on figure 4. Same for difference voltages and polarities. 5.2 Particle sizing and number density measurement technique. The laser Doppler system was used to size and count the solid particles in the exhaust gases of the engine for both fuels. Then the measured and calculated particles number density and their collection efficiency were compared and found very close. Particle size. All the present calculation based on the laser mean measured particle size of 3.2498 within percentage of error equal to plus minus 12.8%. The measurement was in micron. Particle number density. By using the laser technique for particle number density measurement, we found that for benzene engine, the particle number density for the lead equals 6.477 times 10 to 7 particle per meter cube, while for carbon equals 6.613 times 10 to 4 particle per meter cube. For diesel engine, the carbon particle number density equals 4.217 times 10 to 7 particle per meter cube. The error percentage for those measurements was plus minus 6%. Those particles were mostly the outcome of the following chemical reactions at about 1273 Kelvin. The two reactions for the carbon formation, question 5, and for the PB formation, question 6. When the lead particle take an electron, it will be neutralized, as in the question 7. The major factors controlling the precipitation process are: 1. Particle charge, second, probe potential, 3 particle plus gas velocities, 4 the probe length, which can be calculated from the following relation. The length of the precipitator can be calculated from question 8. Note that we notice in cold atmosphere and due to the humidity some similar rate of particles were precipitated on the neutral pole. The collector center were also examined under the microscope and the results are shown on figure 5, where the carbon distribution was clearly disturbed by the electric field. Figure 5, microscopic examination to the new and used pole plates. A new plate, B used plate. B previous work. Our previous work on similar technique was done in 1984 on the low pressure burner system as shown on figure 6. The project was supervised by Professor Derek Bradley from the University of Leeds in England, by which we achieved very successful result. Within that technique, we used the methane air low pressure flame seeded with either alumina Al2O3 or graphite C particles of micronic sizes. The laser electrostatic technique showed that for aluminum particles of mean size 2.65 micron, the hot charging caused a high particles precipitation on the probe reach up to 100% efficiency, while similar investigations were done on the same flame seeded with the graphite C particles of mean size 3.75 micron, and the results were very useful to estimate the burning rate of the carbon particles. It was a new and encouraged technique based on the following theoretical relation. Number 10. C. Other work. Based on the same technique, beside the magnetic ones, we suggested the following future work, and we already started some of them, like air conditioning filter was tested in Jordan in 1999 and was very successful. Number 2, carburetor breather and magnetizing the inlet petrol. Number 3, domestic air cleaner. Number 4, lubricant oil filtration, tested in Libya 2003 and was very encouraging. On the air conditioning filter, we did 2 papers. The wind tunnel, where we use the system introduces on figure 7. Number 2, for domestic air cleaning and refreshing, we use the system on figure 8. By using the first system, we investigated Baghdad, Iraq weather through the period 1991 to 1993, where the obtained results shown on figure 9. It is clear from the figure that the highest mass deposit on the positive pole of 28 DC voltage, while the air velocity was as low as 12.5 meter per second. But at higher velocity, the deposit mass will be reduced as presented on figure 10. Further, that some of the mass deposited was noticed on the neutral precipitator, but less than on the other charged ones. Figure 7 shows the air filtration with wind tunnel. Figure 8, air filtration and refreshing for domestic purposes. Figure 9 show the relation between the precipitator's apply voltage and the mass rate of the precipitated particle for Baghdad weather. Figure 10 shows the relation between the air velocity and the particle collection efficiency for Baghdad weather. For the domestic system of Figure 8, the AC current was used to excite the oxygen molecules till a certain level by the DC current, besides the other processes like air cleaning and refreshing. By using both types of current at certain level, we have to make sure we are not ionized the air molecule, i.e. no gaining energy higher than 1.06998 times 10 to minus 18 joule. We design our safe system on the following specification: precipitator width, precipitator length, precipitator's gap. Furthermore, it is well known from the previous research that the minimum required energy for electric discharge within the air molecules is about 1.53 times 10 to minus 12 joule per mole. This phenomenon can be used domestically to demolish all the air germs and bacteria. Further medical advice will be more useful. 6. General conclusions. From the present work, we can conclude the following major points. Number 1, dust can be easily charged to any level by the electrostatic field. Number 2, atmospheric dust might hold heavy charge and could be dangerous. Number 3, those charged dust can be easily precipitated by any precipitators, even with the low charging level. Number 4, DC positive electrode was found effective in such process. 5, magnetic field could be also useful to employed for double purposes. First, collecting iron dust. Second, to energize the oxygen molecules. 7. Discussion on the vehicle dust. The number of cars and vehicles have been increased dramatically through the world, and they become one of the main sources for the solid pollution. So we have to give some attention to their dust. And from our work, we concluded the following points. The particles of such dust are vary in both sizes and charges depending on the machine following parameters. 1. Engine design, running hours and load. 2. Fuel types. 3. Exhaust type and length. But even with such charging condition, we found from the present measurement that the particle sizes fall within the range 0.05 to 5 micron. According to the 1993 American emission standards, that the modern vehicles must be emit less than 0.2 grams per miles. So let us assume that for millions cars, the total solid emission will be annually about 730 tons of both carbon and lead materials. This calculation was based on the average running miles, which is 100 miles per day. More surprise that if we take the 100 countries in the world, then the total ejected must become 73,000 tons and might be doubles when we include USA cars. Now you can imagine the horrible figure will be when we include all the other emitting sources. 8. The world requirement For a clean environment, the world needs the following suggestion. We estimate the required number of stations to be assembled around the world. Now from question 11, we calculating the amount of airflow rate through each station. Then follow the calculation, and after 50 years, we need 161 stations per each country to clean our atmosphere from the following dusts, as in table 1. Table 1 shows the mass density of aerosol particles suspended through the atmosphere of the large cities. Number 9, references. We use those references to support our present work. And thank you very much for the audiences.